Okay, well, let's now look at the other type of special series that we want, and that's the geometric series. Now, the definition, you'll notice, is quite similar to the arithmetic one. The only difference is instead of adding a constant amount, we're now multiplying by a constant amount. And that constant amount we call the common ratio. So we symbolize it with an R. So if we wanted to work out that ratio, well, second term divided by the first term would do it. Our third term divided by the second term would do it. In fact, we could get any term and divide it by the term before it. So term n divided by term n minus 1. That allows me to create the recursive formula for a geometric series, just rearranging it to make Tn the subject. We get Tn is equal to R times Tn minus 1. So as I say, that's our recursive formula. Well, let's try and calculate a general term. So the first term is A, then the next term we would multiply it by R, so AR. Third term, AR squared. And pretty soon we've developed our pattern. The general term, term n, will always be AR to the n minus 1. Now, if we were to plot this type of series, the graph here would be an exponential function because the n is now in the power. Have a look at this example. 2, 8, 32. Let's find the ratio and then create a general term. So A is 2. Our ratio there, it looks like we're multiplying by 4 each time. So general term, AR to the n minus 1. Substitute in 2 times 4 to the n minus 1. Well, that is a formula, but we can do better than that because 4 we can rewrite as 2 squared. And playing with our index laws, we get 2 times 2 to the power of 2n minus 2. We can keep going, and we end up with 2 to the power of 2n minus 1 for a formula. All right, we're told the second term of a pattern is 7, and the fourth term is 49. Again, we've got to find what the general term would be. So the second term, AR, is 7. Fourth term, AR cubed, is 49. Simultaneous equations. But this time, instead of adding or subtracting to eliminate, I'm going to divide. So R squared is equal to 7. I've divided the second line by the first line. Well, actually, that gives me two possibilities for the ratio, plus or minus 7. Summing back in then, A would end up being plus or minus the square root of 7. So our general term, well, if A is root 7 and the ratio is root 7, then I'd end up with root 7 times root 7 to the power of n minus 1, root 7 to the power of n. But if the first term was minus root 7 and the ratio was minus root 7, I end up with minus root 7 to the power of n. Now, when we have a negative as a general term, we tend to factorize out the negative 1 because all that negative 1 to the power is doing is saying, hey, these terms will alternate. So what we're now looking at is two possibilities for the general term. They're both the square root of 7 to the power of n. In one of the patterns, they're always positive. In another pattern, they alternate. Which one is it? Don't know. They've got to give us more information. So until they do, we have to say, well, there's two possibilities here for the general term. What would the first term of this pattern, 1, 4, 16, what would be the first term that's greater than 500? So first term's 1, the ratio is 4, so we can work out our general term, AR to the n minus 1. Well, that's just 4 to the n minus 1. We're saying when is that general term greater than 500? So when is 4 to the power of n minus 1 greater than 500? Now, we could just guess numbers here and substitute in and see what happens, but it's more efficient to use logs here. We've got an exponential, so to undo the exponential, log both sides. That allows me to bring the n minus 1 power to the front, divide both sides by log 4. I get n minus 1 is greater than 4.48, so n is greater than 5.48. N has to be an integer, so the first one bigger than 5.48, well, that would be when n is equal to 6. So the sixth term, which turns out to be 1024, would be the first one bigger than 500. So similar sorts of questions for the arithmetic one. It's just now that we're multiplying the terms instead of adding a constant amount to the terms. It's just that we're multiplying each term by a constant amount rather than adding each term by a constant amount. I just want to now look at this idea of arithmetic and geometric means. What on earth do they mean? Pardon the pun. Well, arithmetic mean, you've actually been working with that for a long time. It's the same as average. That's why we sometimes call the average the mean. And it's simply then, as is average, add all the numbers up and divide by the number of numbers that you have. Well, geometric mean is when we are dealing with a geometric pattern. So the geometric mean, instead of adding all the numbers, we multiply all the numbers together. So A1 times A2 times A3, however many we have. And instead of dividing by the number of terms, we find the nth root. 2 terms, you find the square root. 3 terms, you find the cube root, and so on. And, well, plus or minus, because sometimes we can't tell. It depends on how much information, whether we can say that that mean is going to be a positive number or a negative number. Most of the times it's a positive number, but you never know. Find the arithmetic mean and geometric mean then of 4 and 25. So just 2 numbers. So arithmetic mean, 25 plus 4 over 2, so 29 on 2. Geometric mean, now it's going to be the square root, plus or minus, the square root of 25 times 4. Square root of 100 is 10. What we've actually worked out is, if we had to place a number in the middle of 4 and 25 to make this pattern, in the first case arithmetic, in the second case geometric, what would the number be? So if it's arithmetic, then 29 on 2 would go in the middle, the arithmetic mean. If it's geometric, 10 or negative 10 would go in the middle. That's why it's plus or minus, because we don't know whether that ratio is going to be a positive number or a negative number. Let's try this one. We've got to find x and y. This time we're going to insert 2 numbers in between 2 and 128. We want to create a geometric progression. So we're going to do this in a couple of stages. X is in the middle of y and 2. So I'm going to say x is the square root of 2y. Now in this case, how do I know it's going to be a positive number? I can tell this time because the first term is positive and the fourth term is positive. Therefore, the ratio must be positive. See, in a geometric progression, all the even terms will have the same sign. All the odd terms will have the same sign. So what I mean by that is the first term, the third term, the fifth term, and so on will have the same sign. The second term, the fourth term, the sixth term, and so on will have the same sign. Now, in that situation, if they're both even or they're both odd, I don't know whether the ratio is positive or negative. But in this case, I've got the first term, 1 is odd, and I've got the fourth term, 4 is even, but they've got the same sign. In that situation, I know the ratio has to be positive. So here I can say the geometric mean has got to be a positive number. So x is the square root of 2y. But then y is in the middle of x and 128. So y will be the square root of 128x. Well, let's play around. They're simultaneous equations. I've got 2 equations, 2 pronumerals. How about I square the second one? We get y squared is 128x, but x we know is the square root of 2y. So 128 root 2y. I'm going to square both sides to get rid of the square root sign. Y to the power of 4 is equal to 32,768y. Let's create an equation, move everything to one side, factorise it, equals 0, so either y equals 0 or y cubed is 32,768. Well, the cube root of that is 32. So there's my 2 possibilities for y. Well, let's investigate that. If y was equal to 0, that's not going to work. You see, you can't have 0 as a term in a geometric pattern because once you have 0, when you multiply it by the common ratio, you're going to get 0 again. So the pattern stops, because every term after that would be 0. So y equals 0 is not possible. Our only possibility is y is 32. Substitute back in, and we get that x is equal to 8. So there's our answer. X is equal to 8, y is equal to 32. All right, let's play with some geometric patterns. So 1C and 1D.